I know it's been a while since I've posted anything. Somebody recently requested me to post a video on solubility product, and that's when I realized we have a few videos to finish the chapter equilibrium. And that's exactly what we're going to do in the next couple of videos. As always, let me know if you find this video helpful, like by dropping a comment or liking this video. And also, as always, let me know if there is a specific topic that you need help with. I will always try to help and upload a video for a topic that you're facing difficulty with. So in this video, we are going to be talking about buffer solutions. By the end of this video, you would have understood why we need buffers. You know the definition of a buffer, the types, and a basic overview on how buffers work. And I recognize that the overview is not really given in your textbooks. I think it's good information to understand how it works to help you understand the remaining concepts related to buffers. Okay, so first of all, why is it essential for us to control pH? I'm going to pause right here and hope for you to answer. If you know the answer, let me know. But basically, the reason we need to control the pH is why we learned this whole chapter. We've understood that equilibrium affects the rate of the reaction. It affects so many aspects of almost anything related to the reaction, right? So a pH, controlling the pH becomes essential in our day-to-day lives, right? From our blood, where the pH is controlled by two very important organs, that is our lungs and kidneys. The pH of blood is typically between, I think it's 7.35 to 7.45. And this pH, it needs to be consistent because our body is essentially a really complex chemical reaction. So the blood acts as a buffer and makes sure the pH stays the same. And various diseases can cause there to be an increase or decrease of pH. So it can either get acidic or alkaline. So the lungs, basically what they do is they remove carbon dioxide, and that's how they control the pH. And the kidneys, they filter out the acid from the blood through urine. The pH of urine is typically between 4.6 to 8. And various diseases, or the way we can identify if the kidneys are functioning properly is by checking the pH of urine. Again, we've talked about chemical processes. We know that pH is going to affect the equilibrium, which in turn will affect the rate of the reaction of any chemical process that happens. The last one is industry. Obviously, in industries, for example, if you think about it, cosmetics, the manufacture of cosmetics, there's buffers added to the cosmetics to maintain the pH. And this will make sure that you don't have really harmful chemical reactions or any reactions happening when you apply the cosmetics to the skin. So controlling the pH is one of the most essential things that we do with respect to equilibrium in our day-to-day lives. So again, what is a buffer? That's what we're going to talk about now. So buffer is a solution that helps resist a change in the pH. Okay, so this is able to do it in two cases. One, when there's a minor change in concentration, and the other one is a minor change by addition of alkali or acid. Okay, now this important word over here is small amount, because you can't add 10 milliliters of any acid to 5 ml of your buffer and hope for the pH not to change. It will change. But in small amounts, when you add a small amount of acid or base, the buffer solution ensures that the pH of the entire solution, pH stays the same. So basically, you need to remember is that the pH of the solution is staying the same despite there being minor changes in concentration by dilution and minor addition of an acid or a base. So obviously, there are going to be two types of buffer solutions that exist. The one which are acidic buffers and the ones that are basic buffers. We're going to start with acidic buffers. So the acidic buffer is going to have An example over here is acetic acid with sodium acetate. It acts as a buffer at pH of 4.75. So this buffer is an acidic buffer because the pH is 4.75, less than 7. And this contains an equimolar quantity of a weak acid and a salt with strong base. So a strong base, so how is it formed? It's formed by reaction of acetic acid with sodium hydroxide, which is a strong base, and this leads to the formation of a salt. So the equimolar quantity of both the acid, the weak acid, as well as the salt with a strong base. Okay, so this is an example of an acidic buffer. It's able to maintain the pH, the acidic pH, right? The next one is basic buffers. Obviously, it'll be able to maintain the basic pH, right? And it has a equimolar quantity of a weak base and a salt with strong acid. So ammonium hydroxide, which is the weak base, is going to have equimolar quantity of ammonium hydroxide and ammonium chloride, right? Ammonium chloride is formed by reaction of ammonium hydroxide with HCl. It forms ammonium chloride and water. So essentially, if you see, it's basically a conjugate acid in the case of basic buffers and a conjugate base in case of the acidic buffers. Okay, so you have a weak base with its conjugate acid with a strong acid, or a salt with a strong acid, right? So these are the two main types of buffer solutions. Now we're going to specifically talk about how it works. So the example we're still going to take is the acetic acid with sodium acetate. Okay, now when you have this solution, when you have this in water, you have three different types of ions that exist. The first one is the acetate ion and the sodium ion, right? That's from the salt. So this is going to lead to the formation of these two guys. And then you have the weak acid itself. And we know the identification, that the reason we're calling it a weak acid is because it does not want to ionize. So it's going to be in the solution as is. Okay. Now, as I said before, a buffer solution works by ensuring that even if a small amount of an acid or a base is added, it is going to make sure that the pH stays the same. That is what a buffer solution is going to do. So when you let's say add a few drops of acid to this solution, what do you think will happen? Now, when you add a few drops of acid, think about this. The first thing that's going to happen is there is going to be a slight increase in H plus ions, right? There's going to be an increase in H plus ions. So what happens is the acetate ion, which is from the salt, so it's going to give CH3COO minus. This ion is going to combine with the H plus ions to give us, okay, wait. I tried. To give us CH3COOH. So we're getting more of the acetic acid. Okay, so it's going to form unionized or undissociated acetic acid, and that will ensure that the pH of our solution is not going to change. Again, only when a few drops of HCl is added. And the remaining, the chlorine itself, Cl minus ion might combine with the sodium ion to form NaCl, which is salt. Okay, so now I said that, okay, we're adding an acid, it's still staying the same. Will this happen for base as well? Feel free to pause right now and try to figure out what would happen if NaOH was added to our solution. So when you have NaOH added, you have an increase of, you have an increase of the OH minus ions, right? So when you have HCl, it's a H plus ions, OH minus when it's NaOH. So what happens is the OH minus ions will combine with the H plus ions from the buffer. Okay, this would lead to the formation of water. And where is this H plus ion coming from? This is coming from the acetic acid. So CH3COOH is dissociating to give us CH3COO minus and H plus. So this H plus is then going to combine with the OH minus ions to ensure that the pH still stays the same. So since the OH minus ions were neutralized, the pH does not change. So essentially, a buffer solution is making sure that the concentration of our H plus and OH minus ions is not significant, which in turn will affect the pH of our solution. Okay, so with that, we're done with a basic introduction of buffer solutions. So we understood what it is, how it works. To an extent, we have had a basic idea of how a buffer solution works and a few examples of why we need buffers in our day-to-day life. I hope that was helpful. In the next video, we will be talking about how to design a buffer solution. We're going to be talking about both acidic and basic buffers. And yeah, check that out.